Okay, so I'm going to be showing NMproject to you. This is going to be a longer video than the previous one. Um, this is a package designed to help you use NomMem if you are an R user. It's open source, it's free. You can go to this GitHub address and find a README there. It will give you detailed instructions on what it is, how to set it up, etc., and how to use it. But I'm going to give you a step-by-step demo here today so you can see it in action. So the first thing before I start the demo is just to highlight the different components of this. So the first component is that it manages the directory structure that you're working in for you. The idea is you get some consistency in how your analysis projects are structured. Then it's also got a code library, what we call the PMX code library. This has a bunch of NomMem template strips we can work from. It's also got a execution side, so you can do script-based NomMem development. The idea is you can script your entire analysis from beginning to end, and you can rerun that if you need to. And then finally, there's a Shiny interface, and that will help you monitor runs as they're working. It'll help you look at results and compare models and that sort of thing. So let's get started. In the GitHub page, if you followed that link, there's a README there, and it's got installation instructions on there. It's designed to be very flexible in the type of system architectures it can be installed in. But if you've got a simple installation like I've got here, this is just a laptop with NomMem installed on it, PSN installed on it, and RStudio installed on it, then actually installing it is just easy. It's just this one command that you'll find on the README, and that will download and install this package for you. And then once you've done it, we can load the package and then create our first project. So you create the project with the make project command, and you specify a directory. I'm going to call this test 14. I don't have that yet. What this has done is it's created an RStudio project, which we can open. So I'm going to open project in a new session. I'm going to find test 14 and open that project. So what this has done is it's created a new fresh session for us to start in. And what that make project directory R function did was that it created this directory structure for you. It's got a scripts directory in here where you can store your R scripts. It's got a models directory where you can do your non-mem modeling, and it's got data directories here for storing your data. So once we're in here, let's start by doing a demo. So we load the package again, and then there's a function in the package called setup nm demo. And what this will do is it will copy the theophylline example plus some model files into the directory structure here. So in the derived directory folder, we've got our theophylline dataset. It's just a normal everyday example dataset that we usually use. It's got some model files here, and it's got some scripts here. And just to show you how we can produce these scripts from scratch, I'm going to take this one. This is a post-processing script. I'm going to delete that. And I'm going to delete the run1.mod as well. And I'm going to show you how we can use the code library to create control streams and data sets in a very easy way. So the code library is something that you can have a look at just by doing the code_library command. And this is basically a directory. If you follow the README, it will show you the R command you need to do in order to set this up. But essentially what it does is it creates a directory somewhere on your computer that you specify. And inside there, it puts in a bunch of non-mems templates and a bunch of R scripts and R templates. And the idea is that you can use these as a starting point to work from in a lot of your projects. So what we're going to do is we are going to use this one here to create a control stream for the theophylline example. So what we can do is I'm going to just copy that name there. We can preview code in here by using the preview function. And here's the template. And we can copy that to our directory by using the copy control function. We're copying it from advan2 in the code library to run1.mod. So it has now created run1.mod in the models directory, and you'll see it there. So that just got created now. Let's take this. The first thing you'll notice is that the comments here are consistent with PSN's run record. So this is a control stream. We can easily use PSN's run record on there. The dollar problem was left blank. The dollar input needs to be filled in. And these are the columns, which I've got written down here. I'm just copying these to speed things up. I know the data set is in the derived data directory. And what we can see is we've got parameters which are mu referenced and log transformed for maximum stability. We've got an Uppsala style error model here, and we need to fill in these theta values. So I've got some initial estimates written down, which I'm going to copy. And what you'll notice here is that there's a coding convention here, and this is my own coding convention. The rule is it goes parameter name, then unit, and then transformation. These are log transform parameters. So by putting the information like this, you make your control file more readable. Already by working with this this template, we've already got a consistent style that we're making use of in all of our templates, and this will filter through into all of your code. So in all of your directories, you'll have a consistent directory structure and a consistent coding style, and that'll make it easy to transfer projects and that kind of stuff. This isn't just for readability though. This is used by the package to back transform parameters so that you can see them on their original scale. You'll notice also that with PSN, everything after the first semicolon is taken to be the parameter name. So this actually helps when using PSN as well, because then the parameter name itself includes the unit and the transformation. So you get easier to interpret PSN outputs by following this convention as well. We've got different estimation methods here. We've got FOCE, IMP, SAM. Most of them are commented out apart from IMP. This is the estimation method that I will usually start with by default. And in here, we've got initial estimation settings that we found from previous work worked well in the majority of different types of models. So I'm going to leave these alone. We've got our $cov there and exposed tables as well. I'm going to just save it. And just within a few minutes, we have created a working control file that now we can run. So let me open up the demo script here. The other thing we need for this demo script is this post-processing script. That is also in the code library. So if I open up the code library again, you'll find that here. And I'm going to get that in to my directory, not with the copy control, but with the copy script command. And here, this just requires one argument because it doesn't change the name of the file, and we've got that in the directory. So we've got our scripts file in there. That means we can source this statement now, and we can do our script-based model development here. The script-based model development is made up of two main commands. So the first one here is this nm function. And what this does is it takes in what you would normally write on the command line to run PSN. And it creates an object. So here it is creating an object called M1. And this object is going to be of a particular class NM. And it contains information that it is extracted from the command that you've written, but also from the control file that you've specified as well. So it is inferred that this is a run type of execute. It's inferred that this is your control file, and it's inferred that this is your directory that it's going to be running in. It has also added this information to a behind-the-scenes database. It's not something you have to interact with, but the database is there really for your safety. So the database keeps track of what outputs and inputs it's expecting from each function, from each run, and it will stop you if you ever try to run something that will overwrite outputs from a previous run. So there's a level of safety in there. It keeps track of what outputs it's expecting. But once we've got this object, we can do various things with it. So one thing that is generally a good thing to do, especially if you're running on a cluster, where each run has to go through a queuing system, is you generally want instant feedback whether your control file has any errors in it or not. And we had quite a simple control file. We don't have any errors. What this did was it just ran NMTran. It didn't run non-mem, and it didn't submit anything to any grid or anything like that. This checks for control file errors and dataset errors. So you get instant feedback there. It's probably worth showing you. So if I stick in an error here, accidentally stick in an extra character there, and then I run NMTran, you see it picks it up. Okay, so those easy problems to fix, you can pick them up straight away. Then to actually run it, we just simply do the run function. And on here, this is running it locally. And what you'll find is, oh, my computer's slowing down a bit. What you'll find is that it gives you back control of the R console while it's going, and that's because it's running in an interactive mode. I'll show you later how we can run things in a non-interactive mode. But while that's running, let's create a few more runs and add them to the database. So I'm going to create a new control file. So I'm going to use the copy control again, and I'm going to copy from run1.mod to run2.mod. And what this has done is it's created a run2.mod. And what it's updated the based on field here, and it has updated the table numbers here. Apart from that, it's left everything the same. So I will run that as well. Oh, I need to create the object and then run it. While that's running as well, there's a few more objects I want to create. This line here is doing a bootstrap on run 1. So I'm creating M1 boot. I'm not running M1 boot, I'm just creating the objects. and adding them to the database. And it's running a bit slow. It's because it's all running on a dual core laptop. I'm running an SSE as well, and a VPC, and an SCM. This is just to show that you can run a variety of different PSN commands here, but they do all have to be PSN commands. It will not work with NMFE. And as that's running, there's various functions you can use to monitor runs as they're going, to get results and that sort of thing. But the easiest way to look at all of that is by opening up the Shiny interface, which we can do now. So you do this by doing shiny_nm. This will open up in your browser the Shiny interface. And what you see here is our database of runs. And so you see all these more expensive runs. We haven't actually run those. But these ones here, these have both finished. And what we can do is we can look at the results. So I'm going to select one, and I'm going to look at the results in the run monitor. And what this is shown is this is the last bit of the control file. If this run was running, this would be tailing the output, and you would be able to see the minimization as it goes. And then you've got these plots, which I always find useful. It's objective function and parameters versus iteration. And with this, you can do a visual check to see if it's estimated or not. You want to skip the first few runs to see if that's looking pretty stable there. Additive error is also reaching a pretty flat point there. This is looking like a reasonable run. They all look reasonably flat. So this view can give you, tells you how the run is going. Then after it's finished, you can look at the results. And what we see here is it's taken the information that we specified via that coding convention in the control stream. So the name, unit, transformation. And it's used that to create a table of parameters. And knowing that this was log transformed, it has back transformed it onto the hours to the -1 scale. It is also, because it knows it's log transformed, it's converted the standard error into a relative standard error. And the rule is whenever there's a percentage sign, it's a relative standard error. Otherwise, it's an absolute standard error. The other thing we can do is we can, for the results, we can select multiple runs. I've only got 2 here. This is going to be quite a simple view, but you can compare parameters for multiple runs at the same time. The rule here is that a parameter value is displayed on the same row for 2 models if the name of the parameter, the type of the parameter, the unit, and the transformation of the parameter is all the same. If one of those things are different, it will split this onto 2 separate rows to give you a kind of indication that you shouldn't be comparing those parameters. And that's about it for the Shiny interface. If we go back to the R session, we can, you see here in the models directory that the directory looks exactly like how it would look if you were just running R in the command line here. And what that means is that other utilities such as Piranha, Census, that kind of thing, you can just, by specifying this as the working directory, you can run all of those as well. Okay, what else can you do? There is a function called check session. So what this does, these are just extra additional functions. This will check your compliance to certain rules that we should be following as we're using one of these NM projects. So one of those rules is you shouldn't be using setwd to change directory. Generally, it's good R practice to stay in the working directory and use relative paths to indicate what's in various subdirectories. So that's what the first test does, and it says it's true because I haven't changed the working directory. It checks various other things. It says false for a few things here. So one of them is our environment info. So let me show you what that does. If I run the R environment info function, what this has done, it has created a text file in the main directory where it's stamped it by when I did this and by whom. It's got the information about the platform that I ran it in, and it's got all the package versions that I'm using here, along with all of the dependencies. How it did this was it looked in the R scripts directory and it looked at the code in here, worked out the dependencies, and gave you that information here. It did it without running that code. So this is a little bit different to just running session info at the end of an R script. This will capture all of the package dependencies in your entire project, as long as your R scripts are all in the scripts directory. But you do that, and now, as a worst case scenario, you always have information about what the environment you ran your code in was. So this says that that was all up to date. It also looks to see if you're following certain good coding conventions, like whether you've got description fields, etc., whether you're specifying the author. And you can see here for these functions here, for these scripts here, I haven't specified an author. So I should put in an author field at the top of those scripts, and then I'll be a bit more compliant. So the part of the thing I didn't show you here is, so we've run both of these models here. Afterwards, what we can do is we're using this goth1 function that we found in the code library, and this should do some post-processing scripts for us. Let's do that for run 1 and run 2. And what you'll find is they get put in the results directory. And looking at this, we've got some very basic goodness of fit plots using expose. So extremely simple, but you can make these functions as complicated as you want. Because the reason why I called this a function template is because it is a function, but it's also a template because it's copied it to the scripts directory, and once it's now in your scripts directory, it's no longer part of the code library. It is part of your project code base. So you can change this however you want. What else? So the code library, just a couple of comments about that. That is a separate GitHub repository that you can also see on my GitHub. And the philosophy behind that is that anyone can contribute to it. Because it's just a directory of code, people don't need knowledge of R package development or anything like that. They can just go into the directory. So if I show you the code library again, they can just go into this directory and just modify these if they found a better way, for example, to code the $error. They modify that, and then that becomes part of the new code library. Then anyone else taking code from the code library will benefit from that change that they have made. So for what we've been doing here is we've been running all of this stuff in interactive mode. So when I ran this, it gave me back control of the R console straight away. And that's because we are currently in this interactive mode. Now, if you want to repeat analyses, you can't do that, because if these lines are running step by step, it will try to run the model, and then immediately afterwards it will try to run the goodness of fits, the post-processing associated with that model. But of course that's going to come up with an error because that model hasn't finished running yet. So in order to get these run commands to wait, we need to run this in non-interactive mode. So if we type this, we end up with we can run this script from beginning to end, and it will follow all of these. It will follow all these steps. We can do some other things as well. So in interactive mode, if I type this, so run M1 and wait equals true. It's almost as if I'm running this and I'm telling it to wait. Then afterwards, I want it to run a bootstrap and a VPC. Then if I push enter now, I won't because it will lock up my screen. It will run M model 1, it will wait for it to finish, and then after it's finished, it will set off the bootstrap and the VPC at the same time. So to summarize, what NMproject tries to do is standardize the way in which we structure our directories and structure our code. Helps you manage that and follow good coding practices without too much effort. Then it provides you with a script-based execution framework that you can run interactively and non-interactively. And then it's got the shiny GUI for a visual way of keeping track of your runs, an easy way to do that. And that's about it.